Welcome all. In the last video, we have seen that the condition for maximum power delivered to load, that load resistance should be same as Thevenin resistance, and then the maximum power formula is Vth square divided by 4 Rth. So you should be careful what is asked, whether the value of R is asked or the maximum power is asked. Accordingly, you should solve the numerical. So now let's see one more example. To determine value of R, so we have to determine the value of R. That means we have to determine RTH. Okay, for maximum power transfer. Full stop. Also calculate maximum power delivered to R. Also we have to calculate the maximum power delivered to the load R. Okay. So what we will do, we will convert this big network into its Thevenin equivalent. That means voltage source in series with RTH resistance. Okay, by looking at this terminal. So first we will try to find out VTH. So we know that VTH is the open circuit voltage. So we will make it open circuit branch over here. So I have made it open circuit, and because of open circuit, current in this 4 ohm resistor is 0 ampere, and voltage drop also across this 4 ohm resistor is 0 volt. So this VTH will come across this 3 ampere current source. So here now the voltage is VTH. This is the same node. So up to this node, the voltage is VTH with respect to ground. Okay, so here the voltage is VTH because the voltage drop across 4 ohm resistor is 0 because of open circuit. No current, no voltage. Okay, so here the voltage is VTH with respect to ground. Now to determine VTH, I will use the nodal equation. I will assume that this node A is at higher potential. Higher potential means all currents are leaving current. So this is one leaving current, this is second leaving current, and this current is also leaving, but it is opposite to the minus 3 ampere, and this current is 0 ampere because of open circuit. Okay, so let us say this is I1, I2, and this one is I3. So by KCL, I1 plus I2 plus I3 equal to 0. Now what is value of I1? What is value of I1? This is I1, this is I2, and this is nothing but I3. This current is nothing but I3 current. So what is value of I1 current? Voltage minus voltage divided by resistance. So voltage here is VTH. So VTH minus 25, voltage minus voltage divided by resistance, and resistance is 5, plus I2 current, voltage minus voltage, VTH minus 0 divided by resistance is 20 ohm. VTH minus 0 divided by resistance is how much? 20 ohm, plus I3, but I3 and this 3 ampere current are in opposite direction, so this will be minus I3 equal to 0. Sum of leaving current equal to 0. This minus 3 will go to that side, so it becomes equal to 3. Now adjust the denominator, so multiply by 4, here also multiply by 4, here also you should multiply it by 4. So denominator is 20, so 20 will be cross multiplied, 20 into 3, 60. So numerator is 4 VTH minus 4 into 25 minus 100 plus VTH minus 100 plus VTH equal to 60. Now this 100 will go to that side, minus 100 will go to that side, so it becomes plus 100. So 60 plus 100, 60 plus 100, 160, and VTH plus 4 VTH, 5 VTH. So I have this equation, 5 VTH equal to 160. So what is the value of VTH? 160 divided by 5, how much? 160 divided by 5, how much? VTH is 32 volt. So VTH comes out as 32 volt. Simple. So VTH is, once again I will repeat, VTH is the open circuit voltage. So because of open circuit, voltage drop across this 4 ohm is 0 volt. So same VTH will come over here. This is the same node. So here also VTH is there, and then I have used one nodal equation to determine the value of VTH. Next, we will try to determine the value of RTH. So for finding out RTH, turn off the independent sources. Voltage source will be short circuited. Current source will be open circuit. So this 5 and 20 will come in parallel. Okay, and this combination, parallel combination, will come in series with this 4 ohm resistor. So that will be the value of RTH. RTH is seen from this load. So simplified circuit is this. So 5 parallel 20 is 5 into 20 divided by 5 into 20 divided by 25. So its value is 100 divided by 4. 100 divided by 25, it is nothing but 4. 4 plus 4, 8. So RTH value is 8 ohm. VTH value is 32 volt. So your R should also be 8 ohm for maximum power transfer. Okay, then maximum power transfer is given by VTH square divided by 4 RTH. So 32 square. So 32 square means 32 into 32 divided by 4 into RTH. RTH is 8. So 4 into 8 is also 32. So this 32 get cancelled. So power delivered is 32 watt. Okay. Now we will see cases of maximum power delivered to the load. Now suppose your load is complex. That means ZS. It can be resistor plus inductor or resistor plus capacitor. So your source is this and your load is also complex. So for maximum power transfer, this load ZL should be complex conjugate of ZS. Suppose if ZS is 2 plus resistance is value is 2 and it is the inductor of value 3J, then the ZL should be complex conjugate of 2 plus 3J means 2 minus 3J. So if your ZS is 2 plus 3J, then ZL should be 2 minus 3J. That means complex conjugate. So this is one case. Now second case, suppose your ZS is complex. That means RS plus JXS. Then and your load is purely resistive. In that case, load is given by under root of RS square plus XS square. So magnitude of this complex number. So magnitude of A plus IB is, or A plus JB magnitude is, A plus JB magnitude is under root A square plus B square. So if it is a 2 plus 3J, then magnitude will be under root 2 square plus 3 square. So this should be the value of RL. Once again I will repeat. First case, both are complex, they both are containing, both are having complex impedances. So in that case, ZL should be complex conjugate of ZS, then only maximum power will be delivered. Second case, maximum power will be delivered when second case is what? Our source resistance is complex but our load resistance is purely resistive. So in that case, load should be under root of RS square plus XS square. Now one more case, suppose it is containing a combination of ZS is the combination of resistor and inductor. Okay, then your ZL must be resistor and capacitor. Or if your ZS is resistor in series with capacitor, then your ZL must be resistor in series with inductor. Okay, thank you.